This is the first episode of devlog showing progress of building voxel-based game. This will be browser-based game, so I will build it in JavaScript using WebGL. WebGL is an API that allows 3D graphics inside a browser. Let's start with setting up camera and camera controls, so we can navigate our world. Next I will add a simple user interface that allow me to add colored blocks. Behind the scene I implemented simple raycasting algorithm that allows me to place blocks near existing blocks. So now I can add new blocks and build something. Let's add some more blocks. Nice. This is my first voxel object. Now I will add some diffuse lighting. Diffuse lighting is the direct illumination of an object by an even amount of light interacting with a light scattering surface. After light strikes an object, it is reflected as a function of the surface properties of the object as well as the angle of incoming light. Diffuse lighting makes surfaces rotated towards light source brighter. Next I will add more colors to the blocks. For the beginning let's make 3 colors, red, green and blue, just to see how different colors look. It looks nice, but let's make it better looking by adding some shading. One of the shading techniques that makes everything look better is ambient occlusion. Ambient occlusion is a shading and rendering technique used to calculate how exposed each point in a scene is to ambient lighting. In case with voxel blocks it is very easy to simulate ambient occlusion, I just need to make corners darker. I do it by counting how many blocks touch each vertex. Next I want to add some textures to my blocks. But since this is browser-based game I will not use pre-rendered texture images, because they are too big for my scenario. One high-quality texture can be several megabytes in size. If I will need tens of textures it can easily reach hundreds of megabytes in total and that is unacceptable for browser game. Instead I will generate all my textures with algorithms. My first texture will be simple Perlin noise texture. Let's use code from Wikipedia. After a little experimenting I got the following result. I can scale it to my needs too. Let's add my new textures to the blocks. And see how it looks. Now we can compare to blocks without textures. Let's try the same with whirly noise. It's sometimes called cellular noise, because it looks like cells. Now I inverted color of cellular noise and clamped a little. The result on blocks looks like this. Let's add some bump mapping. It is a technique used for faking the lighting of bumps and dents. It is used to add details without using more polygons. I will use the same texture for bump mapping that I used for colors. Let's look at the result and compare with the version without bump mapping. On the right we can see version without bump mapping, on the left is one with bump mapping. Now I have combined all basic rendering techniques, lighting, ambient occlusion, color textures and bump maps. Let's try to make some real blocks, for example. Stone. I changed color to gray and used same inverted cellular noise texture, but stretched it in Z-axis. I think it looks pretty cool. That's it for today. In the next video I will try to create more textures and more block materials.